This lesson is for Advanced Algebra, Lesson 8.1 on composition of functions. When you do a composition of functions, you'll be substituting one equation into the other. There's two types of composition questions that students need to be comfortable doing, and I'm going to show you both of those today, or in the video. First of all, we're going to look at the composition symbols that you might come across. First of all, the little open dot circle is the composition symbol itself, and when you read that out loud, you say follows or following. So g, or function g, is following function f. So that would mean that function f is first and g is second. Could also do it with g of x with the parentheses with the x in function notation. Could also do it with parentheses. Notice that the f is on the interior of the parentheses, so the f function would be first. The g function is on the exterior of the parentheses, so that would be second. So when you read these, you would say the composite of g following f, or the composite of f and then g, or g of f of x. The first type of composition question that students are going to need to be comfortable handling is when they are asked to evaluate a function. And the method that you'll use there is simply plug a number into one function and then the answer or the result into the second. So what they'll have to do is give you two functions like they're doing here. F of x is negative 2x squared, g of x is 6x plus 1. The first thing they ask you to find is f of g of 2. So the way that that's printed or worded right there, 2 needs to go into the g function first, and then we're going to take our answer and plug that into f. So I'm going to start by focusing on the g function, and I'm going to substitute in a 2 everywhere I see an x or a variable. So I'm going to do 6 times 2 plus 1, and then I just use the order of operations there. And let's write out what we did here. We're plugging 2 into g, answer into f. So if I do the order of operations here, I need to do 6 times 2, which is 12, plus 1 is 13. Now I'm going to do f of 13, and I'm going to see what I get for that. So I'm going to take negative 2 times 13 in parentheses, and then square. It's going to be really helpful for students when they do the substitution part. If they put the number that they're substituting in inside parentheses, it just makes it a little bit easier to identify what's going on. So then again, order of operations here, I'd want to square the 13. Don't multiply, you want to do the power first. 13 squared is 169, and then I multiply that by negative 2, so I get negative 338. And so that's my answer for the first one. Let's see if we go in a different order if that gets us a different result. This time we're going to plug 2 into f and then our answer into g. So let's write that out. So if I plug 2 into f and then my answer into g, let's see what happens. This time I'm going to focus on f, and I'm going to write 2 times 2, because I'm substituting that in for x, squared. 2 squared is 4, 4 times negative 2 is negative 8. Now I'm going to do g of negative 8. So I'm going to plug negative 8 into the g function. So everywhere where I see an x, I replace it with a negative 8 in parentheses. 6 times negative 8 is negative 48, plus 1 is going to be negative 47. So that's evaluating a function by plugging one number into the first function and then your answer into the second. The other type of question that students are going to have to be comfortable dealing with as it relates to composites is finding a new equation for a composite. What's going to be happening there is that you're replacing or substituting the first function in place of the independent variable in the second function. My hint here for students is to try writing out the second function and replace every time you see a variable with a set of empty parentheses. So let me illustrate what that looks like on this example. They want us to find g of x following f of x. So that would mean f of x is first, g of x is second. So we would plug f into g. First always goes into the second. First into second. So we're not going to be calculating and getting a number here. We're plugging one function into the other. So the second function is the one that I'm going into. So I'm going to focus on what g of x looks like. G of x looks like 0.75 times something. Currently that something is an x, but I'm going to be replacing the x with all of function f. So in the empty space now where the variable was, I'm going to replace it with function f, x minus 500. Now you could leave it like that if you wanted to, but a lot of times they're going to want you to simplify or get rid of parentheses. So if we did that, let's see what happens. If we did the distributive property here, 0.75 times x is just 0.75x, and then we'd have to use a calculator here, 500 times 0.75, and then we're just going to subtract, so we end up with 375 there. So then that would be our final answer without any parentheses. So that was us plugging f into g. I want students to give it a try. First of all, plugging a number into the function and then your answer into g, and then try it again by plugging the function into the other function. Go ahead and pause the video and then I'll explain here. So this happens to be question number 6 in the homework. If you plug -3 into f, that means I'm going to do -3 squared plus -3 plus 1. So -3 squared is 9, plus -3 plus 1 ends up being a 7. So now I need to do g of 7. So I plug my answer that I got from f, and I plug that into g. So students can technically ignore the g that's sitting outside there. That's just waiting for me to deal with later. So when I do g of 7 now, I do -4 times 7, which is -28. The other question that I asked you to do was number 7 in the homework. This time you're going to plug f into g. So I'm going to focus on what g looks like. G looks like, because it's the second function, g looks like -4 times something. In place of something where the x should be, I'm going to replace it with all of that. So when I plug that in, the -4, to get rid of the parentheses, gets distributed. So I do -4x squared, -4x, and -4. So then I get a brand new equation. Composition of functions takes a lot of practice, so please students make sure that you do the homework. I will also be handing out a worksheet which will give additional practice items here.